welcome to Sunday's edition of Cracking the Cryptic. And today we're going to be having a look at a puzzle called Arrow Clashes by Sktx. Now this is meant to be quite approachable today, 3 stars out of 5 for difficulty, and a very simple rule set where you can see that I guess it's called Arrow Clashes because lots of the arrows seem to meet in cells around the grid where, well, presumably the digits we can put into these cells cannot really clash, but the arrows are sort of doing war. They're head-butting against each other, and that presumably gives the puzzle its title. Now, before I read you the rules, which are very simple, and apologies for my voice, I'm still testing positive for COVID, so apologies if it does grate more than it should do. I need to say happy birthday, though, to Alana. Now, Alana, your boyfriend Johnny got in touch with us to tell us that I think today is your 21st birthday. I hope I've got that right. And Johnny also told us that you were the first person to buy a Cracking the Cryptic onesie from our merchandise shop, which is absolutely incredible. And I think you've been watching for a while and enjoying the puzzles, and we are very grateful for that. Very grateful for the onesie purchase, and we hope that you have an absolutely brilliant 21st birthday. Yes, it was my 21st birthday just a couple of years ago, and I do remember the celebrations were joyous and they went on into the night. So I hope that your cake eating, I hope it can go on for many hours yet. Now, other than that, we got a couple of emails yesterday all about the Dutch Puzzle Championship, our Dutch Puzzle and Sudoku Championship, which took place over in the Netherlands. Let me show you. I got sent some pictures of this. This is really cool stuff because I think some people, found that they were Cracking the Cryptic people, and they were also at the championship. So there are many names that I'll read out some of the names of these people in this picture, and you'll recognise some of them for sure. This is Teasy, Akali, that's Kodek, I think that's Piotr V, Peter Venus if I'm not mistaken, Prime Weasel, TS Swagger, Angelo, so they were all there. I think Cheel Beanhacker was there competing in both competitions. I think he gave an amazing account of himself. And the winner, Tom Groot Cormelink, he's certainly appeared on the channel before. Tom won the Puzzle Championship, and the Sudoku Championship I think was won by Dennis Keatman. So very well done to those two. Fantastic solving, obviously. But it just tickled us pink to hear how many of the people there watched Cracking the Cryptic, and that you could meet each other in real life and find real life friends as well as the virtual friends that we all are. This is great news. Other than that, what do I need to tell you? There's a new puzzle pack being released on Discord in the next day or so by Glum Hippo. Parity Party puzzle pack. I think it's got loads of very famous constructors have contributed to it. So people like Clover, and in fact I'm not going to attempt to list all of the people because I will then miss out famous Sudoku names and get into trouble. But yeah, if you like Parity Party, check that out. That's coming out very soon. I still haven't drawn the names of the winners. I'm so sorry for the June reward over on Patreon. This was the Japanese sums packs. I will try and do that this afternoon. I will make that my mission. Other than that, what else? Just if you are patrons, look forward to the Joseph Namer puzzle pack that we've got coming out on the 1st of July. That is going to be mighty indeed. Now, that's all I've got to tell you. Let's get on with Arrow Clashes and see what Sktx has got in store for us. The rules are as follows. Normal Sudoku rules apply. Digits along an arrow must sum to the digit in that arrow's circle, and that is it. So what does that mean? That means you add the total of those 3 cells up. Let's put, 2, 3, 4 in. Then they would add up to 9. Well, not 0, 9. And so you put 9 in the circle. And that is it for arrows. One of the simplest rule sets you'll ever find, but can lead to some of the most beautiful logic you will also ever find as well. So do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. And the first thing I'm seeing here, which is quite generous actually, in modern Cracking the Cryptic terms, is that lots of these arrows, well, although they share cells, they are at least 3 cells long, and 3 cells long where we can't repeat digits. So for example, this circle here, the minimum we could put onto these arrow cells would be 1, 2 and 3, which add up to, you've guessed it, 6. The same is true for that one, 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 looking into box 6 for its 3 rather than these two or these two, and the same is true for that one. So each one of these circles is at least equal to 6. And okay, and can we just do maths on these boxes to sort of work out, well, yeah, okay, we can improve on this slightly, can't we? Because let's use maths. What is the minimum sum of those 5 digits in box 4 there? Well, if I filled them with 1, 2, 3, 4 and 5, they would add up to 15. But that wouldn't give us the totals for the arrow circles, because this cell is on 2 arrows. So we'd need to be, in terms of working out what the arrow totals would be, we'd have to include this digit twice. So the minimum that arrow circles can be would be 15, and if we had a 1 in the middle, the 1 would get counted twice to give us 16 for the circles. Now if 16 is the minimum for the circles, you can't have a 6 in either of those cells, because you'd have to put 10 in the other one. So actually, look at that, we get an improvement. And this, well, yeah, there's hardly any degrees of freedom on this, because if this central digit, yeah, okay, I was just wondering whether it could even be as high as 3, because that would imply that if we minimize this with 1, 2, 3, 4 and 5, but put the 3 in the middle, so the 3 gets double counted, these would add up to 18. And at first blush I thought that could work with double 9, but no, it doesn't, does it? Because then Sudoku breaks that party up, because we'd have to put 9 on an arrow, and there is no way you can put 9 on a 3-cell arrow, because you will find once you add other digits to 9, you get double-digit numbers for that circle. So that doesn't work. So I think this central cell here has to be a 1 or a 2. I think that is what this is telling us. And it's not like we can put loads of high digits on the arrows here. We really can't. If this, well, yeah, let's explore that. If this is a 2, does that mean we have to be using 1, 3, 4, 5? Because otherwise we would break. Yeah, we can't make these 2 circles add up to as much as 18, because then we'd have the double 9 problem. So yes, if this is a 2, the other digits are 1, 3, 4, 5. If this is a 1, it's a little different, because we could have a 6 on an arrow. Let me just think about that for a second. If this was 1 and we went 2, 3, 4, 6 into the other cells, then ignoring the double count, these cells would add up to 16. The 1's double counted, that gets us to 17, and we could have 8, 9 in the circles, and that would work. So, okay, so the central digit is a 1 or a 2. Well, that's for this box though, although, yes, okay. So look at the pentomino formed by the circles here. It's exactly the same pentomino. The arrows basically work the same way, don't they? So all of that logic I've just done there must apply, sort of mutandis mutandi, or whatever the expression is here. So this is a 1 or a 2. And what's more, this one's already lost its ability to be 6, but that one can lose its ability as well. And we will provide the kryptonite to these circular supermen and remove their powers. Now in this box, 1, 2, 3, 4, 5, no, it's the same. Although the pentomino is different, that one's a Z pentomino, although it's been sort of reflected. The logic is the same, isn't it? That we still have to put a minimum of 1, 2, 3, 4, 5 into the into the Z pentomino, that's the minimum we could put in, that would add up to 15, but we know these circles, yeah, the circles work the same. We can't have double 9 in there, because that's going to put a 9 on a circle in the box. Not a circle in the box, it's going to put a 9 on an arrow in the box. So the central digit again has to be 1 or 2, and we can get rid of the 6s. More kryptonite. Now this one, however, is different. That is not even a pentomino. That's a very sickly looking sort of, well, I'm not even sure. It's not even approaching being a tetromino, because this is not orthogonally connected. It's sort of a broken giraffe. And well, so the minimum value of those cells would be 10 if we made them 1, 2, 3 and 4. The minimum value of this would be a 1, so that means the minimum value of these two circles is 11, and we've already worked out that these, oh, is that, no, that is right. I was just wondering whether I'd actually made an arithmetic error by making this as much as 6, but that is a 3-cell arrow, so that is correct. And this one gets its restriction not from this short stubby arrow, but from the Z pentomino in box 6, so that's still okay. But yeah, so in the theoretical minimum for these 4 cells, or these arrows, is 50. It's not 15, it's 11. But obviously we can never actually make them add up to 11, because if we minimize them, they're going to add up to 13. But yeah, I think box 2 is a lot less restricted than boxes 4, 6 and 8 by the looks of things. So what are we meant to notice now? Do we have to have a 9 in one of the sides? The answer is yes, because, yeah, okay. We could have gone double 8, but double 8 gives us the same problem double 9 gives us. Double 8 puts an 8 on a 3-cell arrow in the box, and that's going to mean double-digit numbers. You know, if we put an 8 here, what's this now got to be? Well, it can't be 8 anymore. It's going to have to be much bigger, and it's going to have to be a double-digit number. So that will not work. So if you can't put double 8 to make 16, but we know the total is at least 16, we're going to need a 9 in one of these two cells. And the same is going to be true. So how on earth do we pencil mark this then? So there's a 9 in one of these two, like that. There's a 9 in one of these two, which is an X-wing on 9. Oh, no, well, it is an X-wing on 9s, but it's a very strange X-wing on 9s. And there's a 9 in one of these two by the same logic, because again, double 8 here would break the arrow cells in box 8. Got it. Right, okay, that's actually beautiful. That is a lovely, lovely idea. Okay, let's come back to what I noticed was this sort of shifted X-wing. It's like a parallelogram rather than an X-wing. So let me just highlight these cells for a second. So these orange cells, each pair of orange cells connected by arrows has to have a 9 in it. So what that means, if you think about it, is that we can ask facetious questions about how many 9s we're expecting there to be in row 3 and row 7 of this grid. So if I ask that facetious question about row 3, what would your answer be? How many 9s are you expecting there to be in row 3? And hopefully your answer would be 1. How many 9s in row 7? Hopefully your answer would be 1. So in these two rows, we are expecting the correct solution to this puzzle to have 2 9s altogether. But we know that there are 2 9s in the 4 orange cells, because we know there's a 9 in one of those, and there's a 9 in one of those. So in terms of these two rows then, we can't put any more 9s in than those that are included in the orange cells. So that immediately wipes 9s out from all of these cells. And the reason that looks interesting to me is look what that's doing in box 8. If you can't put 9s in the green cells, where are we going to put 9 in this box? It's going to have to go in one of those two cells, which means this is not a 9, but we knew one of these two was a 9, so we now know it's this one, and we've broken up our parallelogram, because that can't be a 9, and if that can't be a 9, we know that's a 9. That's lovely, isn't it? That is lovely. So we can get rid of our green now, probably. We've got 2 digits. I can get rid of 9 from there by Sudoku. We can... What else can we do? We can pencil mark some 9s in the grid. That might be... Yeah, 9's got to be in one of 2 places in box 1. 9 in box 2 is in one of 3 places, I want to say. 9 in box 6 is in one of 2 places. 9 in box 9 is in one of 1 place because of the 9's pencil mark down here. So this is a 9. So, okay. Right, so there's a 7, 8, 9 triple in this row now, because this digit, yeah, in fact, let's get rid of the orange for a second. Because this digit, where does it go in this box? I might want to get rid of the blue as well. Actually, let's and now I'm going to have to get rid of all orange, because I'm not sure whether these are the same or not. These could be the same digit, but they don't have to be. So probably best not to have them coloured the same. But this digit, let's actually recolour this one and ask where it goes in box 8. Can't go in these cells. Can't go on a 3-cell arrow, because if you put a 7, even a 7 on a 3-cell arrow, once you add 1 and 2 to it, which is the minimum you could add, you'll get a double-digit number. So this 7, 8 goes in one of those cells, which means that these cells are selectable from 7, 8, and we know one of them is a 9 by Sudoku. So that makes a triple in the bottom row. Look, 7, 8, and 9, and probably we might have to start thinking about colouring 7s and 8s, because I know this one is in one of those 2 cells, and this one is some other 7 or 8, which has to go in box 6 somewhere. It's got to go in one of those cells. So there is now a 7, 8, 9 triple in this column as well. So, okay, so there's a lot of symmetry. Actually, no, it's not. No, it's not quite the same, is it? It's similar ideas, but it's not actually giving symmetrical positions for things. In the sense that this, the rotationally equivalent cell, you know, if we rotate around the negative diagonal, we'd end up in this cell. So we have similar ideas giving rise to the 7, 8, 9s, but not quite the same geography within the boxes it affects. Right, so what's this telling me? So yeah, okay, so the orange digit in box 6, I don't know where it goes, but I do know it's in one of those 2 cells. So that means where do the 7 and 8? Yeah, okay, I need to grey flash this because one of these is a 9. Okay, so where does 7 and 8 go in column 8? And the answer is in 2 of these 3 cells. But I can't put them both on the 9 arrow because 7 and 8 add up to 15, not 9. So this digit is a 7 or an 8, but I don't know which colour it is. And there's a 7 or an 8 on this arrow, which must go with a 1 or a 2. Right, that's quite beautiful actually. Again, look now, that's well, 1, 2, 7 and 8 are now a quadruple in the column. So the rest of the digits have got to be 3, 4, 5 and 6. which, well, I can never put 6 on an 8 arrow or on a 7 arrow because it's too large. It can go on a 9 arrow, so this could be 9, 6, 1, 2. But okay, so 7 or 8. No, this box is just underpowered compared to the others. Well, okay, well, let's try the same logic then. Let's rely on the perverted symmetry. So blue in this box can't go on an arrow. So blue is in one of those cells. And therefore, now by perverted symmetry, 2 of these 3 cells are 7s and 8s. But we don't know which ones. Oh, or do we? Right, we do know this. Well, I know this one. This one goes there, I think, in box 7, because this one, where does it go in this box? This is going to get very awkward because I don't think I know what colour this is. It's obviously either orange or blue. Let's give it both of those colours then. But it goes in one of those 2 cells. And then by Sudoku, because we know that the 7 and the 8 in this box are in these 3 cells, it must go here. So this is definitely actually a 7 or an 8. And it's the same as this one. So maybe I give this a different colour then. Maybe I just label those 2 up or something. And they go into one of those cells. Ah, okay, that's really clever. This is a very interesting puzzle. It's got a weird logic. Column 2 then. Let's just do the same thing in column 2. And ask about 7s and 8s, because we know one of these is a 7 or an 8, so neither of those is a 7 or an 8. Now you can't put 7s and 8s on 3-cell arrows, so they're not in those cells. So in this column, there has to be a 7 or an 8 in these top 3 cells. Now that's going to create, look, a virtual 7-8 pair. We know that the 7 and the 8 in box 1 are in 2 of these 4 cells. And therefore that cell cannot be a 7 or an 8, and that's a 6. So this is a 1, 2, 3 triple, adding up to 6. That's got to be big. Oh. Yes. So where does 6 now go in box 4? Now, right, it can never go on an arrow adding up to 7 or 8, so it's not here. It's not here by Sudoku, it's not a 1 or a 2, so it's not there. Now, if the 6 was here, these 2 cells would have to be a 1, 2 pair to add up to 9. So we'd have to go 6, 1, 2. It's the only possibility that gives rise to a single digit total. Now that's going to break row 5, look, we'd have too many 1s and 2s in. So that's not right. And if that's not right and the 6 isn't here, could the 6 be here? Oh, I thought I was going to get a 6, 9 pair. Now I'm not so sure. If that's a 6. Oh, that could work. Oh, you rotten thing. Right, okay. So we don't know where the 6 goes, even to within 2 sort of cells in box 4. We know it's in one of 3 cells. That's what we know. So we know it's in one of 2 cells in box 7. But we've got the same problem. Or hang on. So where does the 6 go in this box then? It's not on the arrow that adds up to only 7 or 8. So it's not on there. It's not in there. It's not there. Now, all I've got to do then is to get rid of it from here and I'll know it's in one of those three, and I'll then know it's there, and I'll know it's in one of those, and I'll at least be able to do some things. In fact, I would be able to place 6 in this column, which would be huge. So how do I avoid this being a 6? If this is a 6, this has to be a 1 or a 2 to make this add up to 9. So this would be a 1-2 pair, and this would be a 3. I don't know if that's wrong or right. That could be either of those things, which is not ideal. What about this little arrow then? If this is a 1, 2 or a 3 and we're adding up to 9, that's got to be 6, 7 or 8. Even my COVID brain knows that maths works. Okay. I'm worried now. I feel like it was going very prettily until I got sort of waylaid by thinking this could be a 6. Can it really? This would be a 1-2 pair. There's nothing wrong with that. There's nothing pointing at that, preventing it. I've got a 7 or an 8. I don't really know how to portray this. I don't want to do 7 and 8 in the column because that's clearly going to look very strange against this cell being a 7 or an 8. Oh, 6. Right, so 6 is in one of 3 places in box 3. No, okay, sorry, that doesn't seem to be doing it either, does it? Oh, okay, let's go back to first principles then. This is a 3-cell arrow adding up to 7 or 8, so it must have a 1 on it. There must be a 1 in one of those 3 cells. Ah, no, oh, I see, it doesn't work the same way over here, because the 9s are upside down because of the perverted parallelogram X-wing thing. Then the 1s are in one of those 3 cells, so we don't get an alignment of 1s. Well, we know this can't be a 1, because there's a 1-2 pair in the row, so that's not a 1. So the 1 in this column is vertical. Or maybe a better way of expressing that, the 1 in box 4 is vertical. The ones in a column are always sort of vertical, aren't they? So this can't be a 1. Yeah, okay, I'm getting stuck, I think. What is it I'm missing here? I've got to put... I feel like my trail of 7s and 8s just ran cold, which is a bit disappointing. Okay, how do we do this then? Can I do better with my 7s and 8s than I have already? There is a question for the ages. I know I've got a 7 or an 8 in one of these, but I don't know the colours down here. That's discombobulating me as well. Oh, all right. Oh, that's weird. Right, okay, right, where does 7 and 8 go in row 2? That's an interesting question. So, because we know, this is a bit hard to see because of the way I've pencil marked this, but if you remember, we said that there is a 7 or an 8 within these green cells. So that means in box 1, these 4 cells contain the 7 and the 8. That means these two do not. So these have not got 7 and 8. These have not got 7 and 8. Now I don't think this one can have 7 or 8 in it because it's got both colours in its column. And I don't think we've already got this 7, 8, 9 triple here, so that one can't be a 7 or an 8. So there are actually only 3 cells in the row that can be 7 or 8. Now, can we do any better than that? So in row 2, these 3 cells are the possible cells for 7 and 8. Ah, okay, and it's the same with 9. Where's it? Okay, where does 9 go in row 2? And the answer is not here, apparently. I do seem to have 9's pencil mark there. Not there because of this 9. So 9 can be here. 9 can be here, I think. Can't be there. 9 and 9 can't occupy any of those cells. Right, so that's the trick. There is a 7, 8, 9 triple in row 2, which means this is not a 1 or a 2, which means this is a 1 or a 2. And this is a 7, 8 or a 9, and this is a 7, 8 or a 9. And that does what? That does... I know one of these two is 9. Okay, I get a 1 or a 2 here. Ah. Oh no, I had a virtual 1-2 pair already, so all I've done is sort of crystallize that. So I now know these 2 digits are the same. What is it? If these 2 digits are the same, no, I don't know what that means. Wow, okay, so sorry, I think this is a complete red herring unless I'm missing something very obvious. It doesn't seem to do anything. So we've got to think harder again. So what is it that I'm meant to be spotting? I've now got... Right, what I have done now is I've got a 7, 8 pair in box 3. But I can't colour them, because all of my colouring started with these 2 down here. And there's no way I think that we can differentiate these 2 until we can... Well, even if I got purple, it wouldn't necessarily do it. Right, so I am well and truly... okay, well this is not 6 then. So 6 is in one of those 3 cells in box 2, which means 6 is not here. This is not doing enough. Okay. So, how do we do this then? Is it going to be something to do with ones? Got ones here and ones here. Oh, I see. Right, okay. So one of these 9s, either this 9 or this 9, is a 2, 3, 4 arrow explicitly. And that's because whichever one of these is a 2, and one of them must be a 2, the 1 in the box gets shunted onto the 7, 8 arrow. So that means you're going to have a 2 on the 9 arrow, but no 1 on that arrow. So it will have to be 2, 3, 4. So either this is a 2 and that is a 3, 4 pair. That could be right. I don't know. I don't see really what the problem is with that. Or this is a 2 and this is a 3, 4 pair. That feels like it's putting more pressure on the world, doesn't it? Just because it's at least... because these align, they are actually looking at something saying, haha, you can't be a 3 or a 4. So hang on, let me think about this. If this is 2, this is 1. So this is either 1, 2, 4, which would mean this would have to be 2, this would have to be 4, or this could be 1, 2, 5. Okay, so that could be a 5, and this could be a 2. Oh no, that can't be a 2. Hang on. No, that could be 2, that could be 4, and that does work. But what doesn't work is if this is 8, because the 3, 4 would knock out the ability of 1, 3, 4 on the arrow, and 1, 2, 5. No, that could still work actually. 5 could be here, 2 could be here. No, it's not enough. It's not doing enough work, I don't think. So this is not, no, it's very frustrating, but I don't think this is the way to think about this. There's got to be something else that... Can that really be a 6? If that's a 6, then this is definitely a 1, 2 pair. That's quite interesting actually. If that's a 6, then that becomes a 3, 4 pair. Oh, that's... So if that's a 6, this becomes a 3, 4 pair. Whereas if this is a 2, that becomes a 3, 4 pair. So there's some weirdnesses going on here. 6, 1, 2. But because that's 3, 4, this has to be 1 then. So this would be 2. Ah, that's it. Right. Good grief. Okay, that's vicious. That is absolutely vicious. Okay, so you have to have 2, I think, thoughts, at least to progress using this line of logic. There may be something much simpler than this, I fear. But this is what I think we've got. What we've worked out is that because one of the 9 arrows is a 2, 3, 4 arrow, we have to remember that. Let's keep that in our brains. Now, if this is a 6, because this becomes a 1, 2 pair, what is forced into these 2 cells now? Well, the minimum they could add up to would be a 3, 4, adding up to 7. But we know that we cannot beat a total of 8 here, so that's the only thing they could be. They have to be a 3, 4 pair with a 1 above them. So we're going to have a 3, 4 pair here. Let's just remember that. 3, 4 pair in this domino. Because this is a 1, this becomes a 2. And the 9 arrow we know is a 2, 3, 4 arrow, because that's what we've just said. So this has to therefore be 3 or 4. And we've got 3 cells in this row now that have to be selected from the digits 3 or 4. And that's going to lead to a repeated digit. It won't work. Let me just go do it really, really slowly. So what we're going to, imagine that's the 3, that's the 4, that's the 1. This now has to be 2. And because the 1 is forced upwards, this has to be 3, 4 to add up to 9. And this cell here has no value. So that is, I guess, the trick. Now, so all that's doing, to be honest, though, is it's getting rid of 6 from here. It's not perhaps going to be the blockbuster we wanted it to be. So 6 in the column is now in one of those 2, though. which gives us an X-wing on 6s in boxes 7 and 9, and play. Aha, that's it. That is useful. So now we've got 6 on an arrow in box 8. It's got to go here. Can't go on this one because this is only adding up to 7 or 8. So that's a 6, which means I've got 3 possibilities for 6 in box 2. So I can't rule into play either of these. But this is now a 1 or a 2 because this has to add up to 9, which means that's a 3. So this is now a 1 or a 2, which means that means that's not a 6 because 6 would need at least 3 on its arrow to add up to 9. So that's what gives us the 6's position in box 2 there. So 6 is in one of these 3 cells in box 5. 6 is in so 6 is now in box 6. 6 is on the same cells that orange is, which is this 7, 8. So these are cells, these are from 6, 7 and 8. One of them is definitely a 6. And that's looking at this cell, which is therefore not 6. So 6 has got placed in box 3. Jeepers creepers. Right, this has got, I mean, it's all interesting, isn't it? But it's not easy at all. Right, but this now can't be a 7 because 7 would have to be 1, 2, 4, and this little digit is not on this arrow, so that's an 8. And in fact, that's forcing so that's a 3, 4 pair with a 1. I see. Here we go. So now we know that that's a 7, I suppose. Maybe that's what we get from this. So now we know that this is a 6, 7 pair. And this is a 7, 9 pair. And right, this is a 5, 8 pair. Let's just do Sudoku, see if that's our friend for once. Okay. That feels like it matters a bit, doesn't it? This 3 is giving me a 4 here. Let's do Sudoku a bit more. And if this is a 7 arrow, then this cell's got to be a 1 or a 2. Because I need this arrow to contain the digits 1, 2 and 4. Well, that can be a 1 or a 2, but I need another digit that's a 1 or a 2. That can only be this one. So this must be the 4, which means I can get rid of some more things. And now this arrow this digit is a 3 or a 5 by Sudoku, which means I've got a 3, 5 pair on my 9 arrow. 3 and 5 add up to 8, so this is a 1. So that's a 1, that's a 2. This is a 2, which means this is the 3, 4, 9 arrow. And the 4 here tells us the order, so that's 4, that's 3. That knocked the 6 into the same cells as the 9, so we've got a 6, 9 pair here. We've got... Now, okay, so do I now know, though, what this digit is? Yeah, I do. That can't be 7, because I need to put a 4 on its arrow, so that's an 8. That's a 1, that's a 5, and that's adding up lovely. And now I know these two squares are 7 and 8, which is lovely, because that means that's not 7 or 8, which means that this square is 7 or 8. Okay. I've got an... Right, can I do something with that? This is a 1, so this is a 2, so this is a 7 to add up to 9, this is an 8. So we can do some more tidying up across the top, look. This is I don't know. This 8 means that cell's a 7. Okay, so that's a 2, that's a 1. Now, can I play? No, I was wondering if I could place 1 in box 3, but I can't actually. Well, I can place 2 in the corner in box 1. I can not place 2 in box 7. This 8 means that's a 9 now, so that's got to be 8, which gets me the 8 and the 5 and the 7 and the 9 by Sudoku using this 7. And suddenly I feel like we've broken all these arrows open now. It's probably famous last words, but it does feel more hopeful. We need 4, 5 and 9 at the top, so that's a naked single. That's a 9, and this and the 5 and the 4 is all done. That's 5, that's 4. So this row needs 1, 4 and 5 into it, and nearly. So that's 1 or 4. 1 or 5, and this no doubt will be 1, 4 or 5. Where does 1 go in the middle box? There are 4 1s looking at the middle box. 1 goes in its corner. Can we do the same with 2s? We certainly can. 2 is there in the middle box. Let's try 3s. Yes, 3 goes here. Oh, bobbins, I thought that was going to resolve the 3 on the right, but no, it doesn't. But it does give me that cell. Okay, that's got to be 9. That's actually a very useful 9. Look what that's doing. Wow, 9, 8, 8, 7, 9, 6 all of a sudden. So that's a 5. And this column needs 7 and 8, which is resolved, which does the 7 and the 6, which places the 6, which places the 4. And all of a sudden this middle cross is almost finished. Wow, okay, so have I done all arrows now? Well, apart from this one. I think I have, so it ought to just be Sudoku from now on. Perhaps not my métier, but let's see. Where's the easiest place to look? 1, 3 and 5. This is a 1 or a 3. This is a 1, 3 or 5. Maybe this row. 1, 3 and 5 again. So that's 1 or 3. Oh, that's better. This cell's a naked single. That can only be 5, which gives me a 1 here, a 4 here, and a 3 here, and a 5 here. Therefore, this needs to be a 1 to complete that row. This is a 1 by Sudoku. This is a 1 by Sudoku, so that's a 2 by Sudoku. That puts 2 in the corner, 3 here, 5 here, 3 and 6 into, that's a 6 by Sudoku then, if that's pencil markings correct. Let's hope it is, otherwise I'm going to have made a ricket. That's a 4. Now we need 7 up here, 3 and 4 across the top, somehow not resolved, a bit worrying. And let's check these, 4 and 5. Yes, 5 does it, look. So that's got to be the 4, that's got to be the 5, that's the 5, that's the 3, that's the 3, that's the 4. And that's all of the digits, but not all the... I'll do the colouring in a moment. Let me just see. Yes, it says I've done it. That was hard. That was... What was that meant to be? 3 stars? I think I've missed something there. I'm sure there's going to be a... I think I've probably missed something around where I had to do the really intricate logic on working out one of these 9s was a 2, 3, 4, and then thinking about whether this cell could be a 6. I suspect there was something better there that I could have found. I will rely on chat and the comments to explain to me what I've missed. But what I was thinking I should do is to make sure I've got all of my 7s and 8s coloured appropriately. So let's just see if we can figure that out. Like this. Let's get rid of all purplage of 8s and all purplage of 7s. And now we ought to be able to just at any moment, once I stop messing around, we should be able to double click the 7s and orangify them, and double click the 8s and bluify them. And there we go. There we go. That's better. It's still right, but it's a bit more chromatically consistent. Thank you very much for watching. That was a very clever puzzle, wasn't it? There was, yeah. The only qualm I have about it at all was that difficulty-wise, it felt tricky. Because although it's fairly clear that these central digits are restricted, you have to work very hard with the 7s and the 8s, the 9s and the 6s to see how they flow around the grid. And even once you've done that, you have to, I think, well, the way I did it was I had to think very carefully about the combinations that existed on those arrows and how they could work together. So yeah, very cool stuff from Sktx. I hope you had a go. Let me know in the comments how you got on. Let me know in the comments what I missed. Just don't be too nasty, please. I have got COVID, and we'll be back later with another edition of Cracking the Cryptic.